Subnetting is the process of one network
Dividing
subnet
large network into multiple small network. This is one line definition of subnetting.
dividing network by two or more networks.
Yes, large network into multiple small network we can say.
Large
Yes, one large network.
one large network.
Yes or
Thank you.
no? Because by
Yes.
default in a class C network, let's say I have network 192.168.10.0/24 slash what is slash 24? This is CIDR value. Subnet must tell you how many network bits are there and how many host bits are there. And slash value is classless inter-domain routing. It will tell you the network bits. Let's say 24. So it is telling me there are in this network there are 24 network bits. Okay. So in this network number of valid host is what? 254. Yes or no? You can calculate. Formula is 2 to the power h minus 2. So h will be what? Out of 32 bits IP address, if 24 bits are network bits, that means 8 bits are host bit. So 2 to the power 8 minus 2, it will be 256 minus 2, that will be 254. Yes or no?
Yes.
This is number of valid hosts in this network. Now, if I will divide this network into two parts, see 192.168.10.0 and this time I am going to say slash 25. That means here we have 25 network bits. Now, how many host bits are there? Only 7. Out of 32 bits IP address, 25 bits are network bits. So there are only 7 host bits. So 2 to the power h minus 2, 2 to the power 7 minus 2, it will be 128 minus 2, 126. You can see over here. Now valid host in one network is 126 and here valid host in one network is 254. That means what we are doing? We are dividing large network into a smaller network. Yes.
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 Now I am going to perform subnetting from class B. Yesterday we had discussed subnetting from class C, and today first we should discuss one IP address, one subnetting from class B. So let me, my IP address is 172.16.10.0 slash. By default CIDR value for class B will be what?
Class
16.
subnet for
Yes,
For
16.
class
sub
B,
class
16.
This
for
is
which
network
class?
bits for class B.
255, 255.00.
Yes, that means there are 16 network bits. So
Yes.
we can denote that with slash 16 also. Okay.
Okay.
Now I am saying what slash value, not 16 but 17. Means I have borrow one network bits, yes or no?
Yes.
So here if I will talk about number of network. So what will be the number of network? 2 power
2 power n.
and n is what?
N is
To power of one.
2 power of 1 because n is 1. We have borrow 1 bit.
That's one
0
bit.
power 1. Yeah.
Yes. 7 hosts left.
Yes, 7 hosts left. That means there are 2 network. And see, if I am borrowing 1 bit, if one network bits is going in host portion, that means we are getting 2 number of network. If 2 bits is going in host portion, that means we are getting 4 network. And we are when 3 bits is going in host portion, that time I am getting 8 network. And if number of network is increasing, then valid host is decreasing because h value is decreasing. Yes or no?
Yes.
Okay. After that, number of valid host. Number of valid host will be what? 2 power
2 power h minus
7.
2 power h and
Seven.
h is what? Not 7, brother. Out of
H-
32 bits IP address, 17 bits is network bits.
S 15.
Yes. 15. Yes or no? Is it clear to everyone?
Yes.
Yes.
And minus 2. So what value you will get? Can anyone calculate? 2 to the power. Hey Siri. 2 to the power 15.
The answer is 32,768.
32,786 minus 2. So you will get this number of valid host. 32766. Okay. This is your valid host. After that, block size. Block size will be what? 256 minus
356 minus.
subnet mask of last octet.
Yeah.
So subnet mask of last octet will be, see, in first octet all bits is 1. Yes or no?
Yes.
8. In second octet also all bits is
1.
1.
Yes.
In third octet, how many bits is 1?
1 rest 0.
1 and rest 0. One and rest
7 0.
yes, and in last octet
All 0.
all 0. Yes or no?
Yes.
So subnet mask will become what? 255.255.128.0. Yes or no?
Yes.
So last one is present in third octet. So we are subtracting actually subnet mask of that octet where last one is present. So that's why I am saying again and again subnet mask of last octet. So that is 128. So 256 minus 128, it will be what? It will be 128. This is your block size, and block size will tell me from where my network is starting. Now we have two network. Yes or no?
Yes.
Sir, I have a question here.
Yes.
You say subnet mask of last octet. Okay. Here, this is in group B, right? If
Yes.
it's group A, then which will be the last octet of group
Then
A?
also, you just need to identify that last one is present in which octet. Last one is present. If last one is present in fourth octet, then we will subtract subnet mask of fourth octet. If last one is present in second octet, then we will subtract to subnet mask of second octet from 256 to get block size.
Okay. If it's instead of 17, if there's 24,
Yeah.
then which will be the last octet?
Then third octet will be what? See,
Yes.
if I am talking about /24, so subnet mask will be 255.255.255.0. Yes
Yeah.
or no?
Yes.
So block size will be what? 256 minus subnet mask of last octet. So this one is last octet. Yes or no? So it will be 255. Block size will be what? 1. Getting my point?
Yes.
Yes.
/2 and actually /24 is default, right?
Yes. 24 is default for class C.
For
For
class C,
class
yeah, it's
B,
default
if
for
we are
class C.
using /24, that means we are performing subnetting. Yes or no?
Yes.
Can
And
we
I
go
have
for
to-
23, 22 or some 20 something?
Yeah. Just wait now. First of all, let me finish this one. Tell me what will be the first network ID? If we have two number of network, this is two number of sub-network actually. Two number of sub-network, subnetted network. So first network will be 172.16.0.0. And second network will be what? 172.16 dot
128.
128.0. We will add block size. Where we are adding 128? In that octet where last one is present. You know, the octet where last one is present is my interesting octet. Everything is happening on that octet only. Yes or no?
Yes.
So this is my first network and this is my second network. Now what will be the last IP address of first network?
250.
16.
168.
101.
126.
No.
127.
120.
127 dot
0.
255 na.
255. Yeah. 255.
Here if you will add
That's the
1,
first.
so it will become 128.0. Yes or no?
Yes.
And here what will be the last IP address of second network?
176.
Yes or no?
Yes.
In each network you can calculate we are getting this IP, this number of valid IP address. This is your what network ID? This one is your broadcast ID. This one is also your network ID. And this one is your broadcast ID. First valid IP address will be 172.16.0.1 and last valid IP address will be 172.16.127.254. Yes or no?
Yes.
My actual network is starting from here and ending over here. This is first network. And if I will talk about the second network, so second network is starting from 172.16.128.1 and it is ending on 172.16.255.254. Yes?
Yeah, is it same with last network? Last IP address?
No.
It's a second IP.
Yes.
Okay, second network. Okay.
So these are valid. These
So,
are
in the
valid.
first-
IP.
Then,
Yeah.
how many IPs are in the first network?
This one 32766.
Sir, do you know what's the second IP of the first network?
Second IP of first network will be 172.16.0.2.
Okay.
Right, dot 3 4 5 6 7 8 like this. It will be 16.255, then 16 dot.
Yeah, when we start the third octet, okay, when we go till 9, right? After 9, then we start from 172.16.1.1, right?
Yes, exactly,
Okay. After 9, right?
exactly like
Okay,
this.
got it.
See, after some time the IP address will be 172.16.1.255, 1.12.255, 1.12.255. After that 2.255.
Okay.
Yes, like this.
Yes.
It will come here 170 127.255 253.
253.
Getting my point?
That's a lot.
There are lots of IP address. So when our network is very large, then only we are using IP address from class B. Like if I will talk about the network of Cisco, so Cisco have lots of branches in each country, in each city. Yes or no? So they need to use IP address from which class? Class B. If we have the small network or a small offices, we will always use IP address from which class? From class C. Now I am going to take one example from class A. Okay.
Okay.
So let's say my IP address is 10 dot 0.0.0. Or let me do one more thing here. Before starting the class B, here I have done subnetting with /17. I am going to use now different subnet mask with same network 172.16.0.0, and this time /.17. Let's say slash is 26. I'm using slash what? 26 or not 26. Let's say use 23. Okay. So can anyone tell me what will be the subnet mask?
255.
See, in first octet all bits is 1,
1.
2, 4, 6, 8. In second octet all bit is again 1.
Yes.
In third octet
It's gonna be
7 bit is on. Yes or no?
7, 7. Yes, yes.
And in last octet all is 0 again.
0.
So subnet mask will become what? 255 dot 255 dot 255 dot
254.
wow.
That means 2.
No,
5,
It will be
No,
yes
one-
254.
4.
Yeah, the third
5.
one is, I think
No, the third one is 254.
Yes
Yeah.
or no? So this time my interesting octet is third octet. Yes or no?
No.
Last one is
No.
Pergent.
No, I think you put 3 to 255. You're supposed to put 2.
This time, no. Yeah.
Yeah, now it's fine.
Yeah, that's good.
Okay. So this time my interesting octet is this octet, third octet. Yes or no? So first question is number of network
Yes.
again. How many number of network we will get? 2 power
7.
2 power 7.
Yes.
Because by default you can see by default CIDR value for class B is 16, and here I am using what? 23. That means I have borrow 7
7.
bits. So 2 to the power 7 means 2 to the power 7 is 60, 128. That is 128. That means here we are getting 128 network. See, now my number of network is large, so definitely number of valid host in per network will be less. Okay. Second is valid host.
2 power 9.
Valid host will be what?
Power
2
9.
power
9 is gonna be 512. 512 minus 2, 510.
2 power 9 minus 2. Very good.
510.
It will be what?
510. 510.
2 to the power 9 will be
512.
512 minus 2.
Yeah, 510.
It will be 510. See, number of valid host is lesser than previous example. Yes or no?
Yes.
From this example, because that time number of network was 2 only, so valid host was very large. But this time number of network is 128. That's why number of valid host is less. Now question is block size. So block size is what?
256 minus 256 minus
Yes, 256 minus
128.
128. No. 256 minus subnet mask of last octet. Subnet mask, or you can say subnet mask of that octet where last one is Pergent. That is
254.
254.
Mhm.
That will be what? 2.
2.
So block size tell us from where my next network will start. So there are C 128 network. If I will talk about the first network, so can anyone tell me what is the first network? First network is definitely 172.16.0.0.
That's
Second
0.0.
network 172.16.0.0. 16.20.
20.
Third network
40.
172
We're gonna add 2.
16.4.0. Fourth network
60.
172.16.60. Then 172.16.8.0. 172.16.9.0. Like this, last network will be what?
172, 16, 255. No, 254. right?
254.0. And next
Why?
network will be 256.
Right here in the last one, you say like 172.16.90. It should be 10.0. Why
Yeah,
not?
yeah, sorry. It is 10.0. Extremely sorry. Then now what will be the broadcast ID of this network? 172.16.1.255.
1 0.
10 or 255?
255. 255.
Yes, 255.
Oh, yeah.
Second network
Uh, 172,
255.
3.
355.
3, 255.
172.16.5.255. Like this, last network will be
255,
170.
255.
Sir, here you say we have two network ID, right?
Yes.
So how we can get more than two?
What
It's
to-
not two.
It's a lot.
It's
not two.
128 networks.
Yes, 128 networks are there.
Oh,
In
okay, that was
previous
plus size.
example,
Okay.
there was two
Yeah,
networks.
yeah. Got
Sorry,
it.
it should be. I think it should be 172, 16, 255, 255.
Yeah, 255 exactly. Okay.
Yeah.
And first valid IP address, you can calculate these things now. Yes or no?
Yes.
Now I am moving to third example. 172.16.0.0/29, let's say. This time tell me what will be the subnet mask directly. 255.255.255.
255, 2. 248.
Yeah, 248. You can calculate, guys.
Yeah, 32 minus
So number of network will
29.
be,
It's gonna 3 and minus 3 hosts.
yeah, you can calculate it by yourself.
Yeah, I already did
This
it.
is like your homework.
Okay.
Number of network will be what?
Number of network 2. How many borrowed?
13.
We borrowed.
I think 13.
72, 92. Give me a second.
Yes, tell me, guys, everyone.
13.
Exactly 13.
13.
Valid host?
3.
3.
3.
Yes.
Only 3.
Yes.
2 to the power
No.
2 to the power 3 minus,
minus
3.
2.
Hmm.
So it will be what? 6. Yes
6.
or no?
Yes.
Yes, yes, yes.
Okay. First network will be
First network
172.16.0.0. Second network 172.16.0.
6.
Block size
8.
No.
No.
256 minus 248. Block size, guys, block size.
Yeah, it's not 8.
I think 8.
Yeah, it's 8.
Block size will be 8. So here I am adding 8 in 4th octet. Yes or no? Not in 3rd octet.
Yes.
Because my last one is present in 4th octet. So till here, till first 3 octet, we will not touch. These
So
are
this is group B. Why we do in third octet? Why we not start from the second?
because see the my
Because it's 29.
yes, my last one is present in which octet?
It's not default.
Okay, in the last octet. Okay, got it.
Okay. After that,
16. 172, 16, 0, 16.
exactly. 16, then 16 plus 8, then plus 8, then plus 8, then plus 8. You can calculate. Yes or no?
Yes.
Now I am going to use one subnetting example from class A. Ten dot or 0.0.0/9. So here guys, tell me what will be the number of network, what will be the block size, and what will be the valid host.
Subnet.
Just please type in chat, everyone. Just I want to match your answer.
Okay.
Can you repeat the answer to the question?
One. No, not one. Network B. 120.
Just I want to actually match the answer of you guys. Everyone is getting or not. Network is 1.
No,
Not possible.
no.
1 is wrong.
Oh, I didn't want to send it. I wanted to go to the next line. I just sent it. Is the subnet mask? Is it correct? Okay.
Subnet mask is required. Number of network. What is 128? Subnet mask is this one. Subnet mask is correct. So your
Yes.
subnet mask is correct. But what is 128? Is it block size? Tell me 3 things. Block
network.
size, number of network, and valid host.
Can I have the screen one more time?
Yes.
Okay.
After submitting, we will start, OSI model. So I want there should be no any confusion in submitting before starting OSI model. Are you guys learning?
Yes.
Okay.
Well, honestly, so far it's kind of the review, but it's really good.
Okay. Okay. Now tell me directly here. Number of network.
That's right.
Just give some 128. Number of network is gonna be 2.
2 power 1.
Yes, 2.
Okay, very good. Valid host.
2 power 24 minus 1, 23. 23 2 power 23 minus 2.
Exactly, 23 minus 2. Now you can see how many valid hosts are there in each network. Yes or no?
Yes.
So generally,
2 power
no one
2
is
power
using.
23. 3 is going to be 83888608.
Yeah, whatever value you will get, you can calculate. Okay.
Minus 2.
After that, block size. This is again important.
256 minus.
Block size.
Yes. 256 minus.
256 minus 128.
Yes.
128. Yes.
So it will be 128. First network will be 10.0.0.0. Second network will be 10.128.0.0.
That's,
Third network. No, we have only two
no.
network.
No.
Yes or
It's
no?
a small. Yes. It's a very small.
Okay.
Yeah.
Pim, can you explain like? Can
We
you
just have
explain
4 IP, right? How many?
Yes, yes.
Okay.
I say the first one like you say number of the network is 2 power of 1. Can you explain this one?
Yeah. See, /9 means 1, 1, 1, 1. In first octet, all bits is 1. In second octet, 1,
1 0
0, 0, 0, like this. Yes or no?
Yes.
So how many bit we have borrow?
1.
1 bit. Yes or no, brother?
Yes.
Are you getting me, brother? Now is
Yes.
it clear? So 2 to the power n, where n is number of borrow bits. This is the network bits which shifted in host portion. Okay. Now can I move?
Yes.
Okay, great.
So yeah, what's the second network of the first octet? I mean the first network.
First network is 10.0.0.0 and second network is 10 dot block size 0 plus block size. After
Okay.
that dot 0.0.
Okay.
And
After
let's.
after 10.0.0.0, which ones will be like 10.128? I mean
Yes.
1.1 .0.0 or no? Like
Next network will be 10.256.0.0. That is not valid. We have
okay.
only two network,
Okay, got it. Okay.
right? Okay, what will be the last IP address of first network? 10 dot
Uh,
127.255.255. Yes or no?
Yes.
Yes or no, guys? Is it clear to everyone?
Yes.
Here, if you will add one, brother. Here, if you will add 1. So this will become what? 256. 256 is invalid, right? So this portion will become 0. Again, you will add 1 in this portion. So this portion will also become 0. So you will add 1 over here. So it will become 128. That is your second network. Done.
okay. Yes.
And last IP address of this network will be 10.120, not 128, 255.255.255.
Yeah.
If I will talk about the first valid host, that will be 10.0.0.1.
1.
Then ten dot 0.0.2. Yes or no?
Yes.
Like this.
Oh, it's gonna be a lot.
Like this. Some network will be 10.0.0.255. After that 10 dot after that 10.0.1.0. Then
To
10
10 dot
dot
0
0
dot 1 dot
255.
255, and then
Then 10
10
dot
dot
0
128,
dot
right?
yes 127
127. Okay, yeah. That's a lot of IP address.
126.255 like this, right? There are lots of IP address. You can see valid host is 2 to the power 23 minus 2. It is huge. Now in the subnetting we are not going to discuss anything else. Just I am going to ask you some question. So you all guys are comfortable? You all guys are clear with the formula?
Yes.
Okay, so directly I am going to show you the question and I will ask you the answer. Okay, I will wait for you 10 to 15 second only for the answer, or let's say 20 to 30 second max to max. Within that you need to share your answer. Okay, so let me show you question. My first question is in front of you. This one. Enter the last host on the network that the host this is a part of. That means this IP address is a valid IP address. This IP address is a valid IP address and it is asking you the last valid IP address of that network. So first you need to find the network ID of this network. Then you need to find the last IP address. So tell me which one is the right answer. These are question of CCNA 200301.
It's D
D?
or B, or maybe
B?
B. Between B and D.
Abdul?
I think it's D.
How you are calculating? First of all, tell me what will be the network ID of this IP address.
Network ID. Good question.
First of all, you will write the subnet mask. You can write subnet mask directly up /27. Can you tell me what will be the subnet mask for /27?
Yes. One. Hold on. 255. 255. 255. 27.
Dot?
Give me a second. 5.
So 254.0.
111.
Are you sure 254? It will be
No.
224, brother.
No. Hold on. 128 plus. I'm not fast. Sorry. 160 plus
27 means 3
32.
bits.
224.
28 plus 64
224.
plus. Yes, very good. 224. So what will be block size then? 256 minus 224.
224.
What will be your block size?
32.
32. Now you can find the nearest number which is divisible with 32 to this number. So this number is divisible, guys, with 32.
32.
No,
6.
not divisible, na?
Yeah.
See, or you can find the network ID directly. First network will be 10.86.86.0. Second network will be 10.86.86. Block size 32.
Oh, the last one is going to be A, I think, right?
Third network will be 10.86.86.64.
Yes.
Now tell me this IP address belongs to which network? To this network or this network?
To the right.
Second
one.
network or third network? Second network?
Second.
So what will be the last IP address? 10.86.86.63. But this is the broadcast ID. It is asking you the last valid IP address. So last valid IP address will be 10.86.86.62.
62.
So which option is
D.
right? Getting my point? Are you able to connect the dot, guys, or not?
Yeah, that needs practice.
You need practice, yes or no?
Yes.
Yes.
Okay, let me take you on second question. Question number 2. Yes. See, here question is, what are the maximum number of subnets and host per subnet for the 192.168.50.247 and
Okay.
255.255.255.254 network. Maximum number of subnet, that means total number of subnet and valid host. Just you need to find two things.
Okay.
If you will convert it into binary, na, this value, so it will be 1,
Yeah,
1, 1
that's
and
what
5 times
I'm
0.
doing. Yeah. That's gonna be a /30, right? No.
No,
hold on.
first of all, tell me how many total number of network. Total number of network will be what? N will be what? 2 to the power n, where n is number of borrow bit.
Yeah.
So this IP address belongs to class B.
Class B
For
3.
class B,
3.
subnet mask is this one.
Yeah, it's 3.
3. 2 to the power 3. So 8. That means definitely option B and option A is
That's
wrong.
option
Yes
C.
or no?
Yeah.
Now we need to find which answer is right from C and D. So for that we need to find valid host. So valid host is 2 to the power h minus 2. H is 1, 2, 3, 4, 5. So 2 to the power 5 minus 2. What value you will get? 32 minus 2.
2.
That will be 30. Means option C is right.
Yeah.
Is it clear?
Yes.
If I will share this file with you guys can solve all question by yourself.
Yes.
Yes.
Or should I discuss each question one by one? Because
No,
now you guys are
you-
not answering.
You can answer tomorrow. You can ask tomorrow because we are just now practice.
Okay.
Just send us this
You
file.
will write down your answer, okay?
Okay.
See, there are how many questions? Let me check. 10, 11, 12, 13, 14, 15,
Just
16,
subnetting.
17, 18, 19, 20. 20 questions are there, okay? So you will write down the answer of all 20 questions, okay?
20 question. What's the file name?
I am
CCNA?
sharing this file in group.
Yeah, I
again.
have it. Yeah, you email. You
Yeah,
you
I
already
email.
sent it, right?
Yeah, I already sent it, but again I am sending it in group as well.
That's perfect. Thank you.
I don't have it.
So that's why I am sending it in group as well.
Okay, that's perfect.
Thank you.
And now we are starting OSI model. If you will have any problem, then again we will come to subnetting.
Okay.
Subnetting Q&A. This one.
OSI.
Done?
OSI model. Yeah.
I have sent it in group as well.
Thank
Okay. But guys, make sure you all will, solve the this question.
Okay.
Okay, if you want to complete the training and till the complete, you should be able to connect the dot. Then you have to perform whatever task I am giving you. Okay.
Okay.
Now, very important question is OSI model. Very interesting and very important topic of networking. OSI model. See, before understanding what is OSI model, first of all, let's discuss why we come up with OSI model. So can anyone who can explain why we need OSI model and why we come up with OSI model?
That's a layer of networks, and we needed to understand and feel the layer of networks.
So before OSI model also computers were communicating with each other, brother.
Yeah, I think OSI model shows how the data transmit from one network to other, or from one host to other host.
But if communication was happening without OSI model also, then why OSI model is required?
Why is required?
Yes.
For the secure transmission.
No. OSI model is not, related to security.
Hold on. No, it's networking.
See what was happening earlier. Earlier, communication was happening between devices, but Dell computer was able to communicate with Dell computer only. Dell computer cannot communicate with HP computer. Getting my point? Because the process of communication that Dell engineer used for the communication was different from the process of HP. The method which Dell engineer used for the communication between devices was different from the method of HP engineer used for the communication. In the same way, the process of Cisco was different from the IBM. That means challenge is what here? How to make communication possible between different vendor devices. Now, between vendor devices, communication is happening fine. Within vendor devices, communication is fine. But between vendor devices, communication was not happening. So actually, we were looking for a common process of communication, common method of communication, common standardization of communication. Getting my point, guys? So that different vendor devices can also communicate with each other. Let's say Dell have manufactured two computer 1 and computer 2 for the communication. They have provide the MAC address on the NIC, everything. They have manufactured the hardware. They have designed the software. Then finally, both computers are able to communicate with each other. In the same way, HP engineer were also working for the communication between two devices, and finally, they also achieved the communication between two devices. But now, question is, method of Dell is different from the HP. So OSI model is a common blueprint. One organization designed one common process of communication, and they have distributed this blueprint to all vendor company and tell them that if you want to connect your devices to the internet, then you have to follow this method only. Getting my point? Now, if Dell will manufacture the computer, they will use this process. When HP will manufacture computer, they will use this process. So communication process of all vendor devices is same. That is the reason why different vendor devices are able to communicate with each other. So answer of this question, why we come up with OSI model, is
Because
to make communication possible between different vendor devices.
Vendors can communicate.
Got it?
Yeah.
Now question is, then what is OSI model? So tell me now, what is
7 layers of network.
Okay, there are 7 layers in OSI model.
Yes.
OSI model is a process which tell us how data ought from one computer. Means, let's say I have computer 1 and computer 2.
How they send data.
If computer
Send and
A
receive.
want to send some data to computer B, so OSI model just tell you the how data will out from your computer and how data will enter in your computer. Means when computer will receive the data, how they are going to process the data, and when computer need to transmit the data, how they will going to process the data. That's it. Getting my point? Like, see, when you are leaving for office from your home, let's say this is your home, this is the main gate of your home. When you will exit from here, from your main gate for the office, before exiting, you will perform some task. Like, you will brush your teeth, you will take breakfast, you will dress up yourself, you will take car key, and then only you will leave your home. Yes or no?
Yes.
Like that, whenever data will out from one computer, computer also need to perform some task with the data. Like, they need to provide the IP address, they need to provide the source MAC address, destination MAC address, to the data, then only data can reach to actual destination. Like suppose this is place A and this is place B. From place A to place B you want to send one letter. If you will send the letter directly, your letter can be never reach to B destination, B point. To send your letter to the exact destination, you are using what? Envelope. On the envelope you are putting the source address, destination address, yes or no?
Yes.
Then only your letter can reach to exact destination. In the same way, when data will also out from the computer, computer have to provide source IP, destination IP, source MAC, destination MAC. These four are the basic requirement of communication. Source IP, destination IP, source MAC, destination MAC. Okay. So hope it is clear to you what is OSI model. OSI model is nothing but a process which tell us how data will out from a computer and how data will enter in a computer. Done?
Yes. That's
Now this is nothing but a task. This is nothing but a task. Now we divide this task into 7 part, into 7 layer. May I know the reason why? Why we divide anything? First of all, tell me that. Why we divide anything? Let's say I have one book of CCNA of 2000 pages. If I will give you this book without any chapter, without any unit wise or topic wise, can you read?
no.
It will be very
So-
complicated, yes or no?
Yes.
So we divide anything to make it easy, yes or no?
Yes. For troubleshoot, for
Yes.
We divide anything to make that thing easy. That's why we divide OSI model also into 7 part. Right?
yes.
You know, you guys are new network engineer in the networking domain. Let's say you are new and I am teaching you. If we don't have, 7 layer in OSI model, it will be very complicated for me to make you understand the concept of networking. This is the reason only that why I am able to make you understand that we divide the process into some parts. Okay. So we divide OSI model into 7 part. May I know the name of first layer?
Yes.
Can you tell me the name of first layer?
Physical layer?
Physical layer or application layer?
Yes. Like
It can be
hop.
both.
Like hop.
It's depend, brother.
Okay.
See, I have one computer over here. I have one computer over here. I want to send some data from this computer to this computer. So while transmitting, my OSI model will be application to physical. Application, presentation, session, then transport, then network, then data link, and then physical. Okay, this is for the transmission. The machine who will transmit the data, for them application layer will be the first layer, presentation layer will be the second layer, session layer will be the third layer, transport layer will be the fourth layer, network layer will be the third layer. Sorry,
I thought
fifth
it should
layer.
be. Sorry, I thought it should be upside down. I thought you start from physical layer, right?
While receiving, physical layer
Oh,
is
it's
layer 1.
receiving, right? So
Yes.
That's why. No, I got it. Okay.
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 So when this machine will send data, data it will generate at application layer. Let's say from here in the browser I am typing www.google.com. So first layer that will come in role is application layer. Application layer will generate the data. After that it will hand over to presentation, to session, transport, network, data link, and to physical. So physical layer is 7th layer over here. And while receiver machine will receive data at physical layer, then it will hand over to data link layer, then to network layer, then to transport layer, session layer, presentation layer, and application layer.
Gotcha.
So for the receiver, application layer is 7th layer and physical layer is layer 1. Getting my point?
Yes.
Flow will be like this: computer A, computer B, application, presentation, session, transport, network, data link layer, and physical layer. Here physical, data link, network, transport, session, presentation, and application. Flow will be like this. Okay, got it, guys? What is OSI model? Till now we had discussed only two things: why we come up with OSI model, so to make communication possible between different vendor devices. After that we had discussed what is OSI model. So OSI model is nothing but a process which tells us how data will out from computer and how data will enter in computer. We have divided the OSI model. OSI model is a task is divided into 7 parts to make it easy. And the name of first layer is application, presentation, session, transport, network, data link layer, and physical. While transmission and while receiving, it is physical, data link, transport, session, presentation, and application. Done. Okay. Now, this upper 3 layer is not for us. Is not for us. On these upper 3 layer, network software works, like application developer, software developer, and software tester. Those guys work on these layer. Our work start from transport layer. Network engineer work on these layer. Network engineer work on transport layer to physical layer. Getting my point?
Yes.
But I will give you overview of upper 3 layer as well, like application layer, presentation layer, and session layer. Now let's understand one by one. Application layer. What is application layer? You know anything about application layer?
No.
It provides user interface. User interface, like if you want to access web page of, let's say, Google server. So how you can access web page of Google server? You need one interface, yes or no?
Yes.
Right? Like who is providing user interface? Like Google Chrome, CMD, Mozilla Fire, right? UC browser, Opera Mini. These applications are providing what? User interface, yes or no? And this application works at which layer? At application layer. Let me show you. This is nothing but application layer. This is nothing but application layer. And this is what? This is user interface. Through this interface only I can reach to Google server, www.google.com. Yes or no?
Yes.
So application layer is nothing but it provides the user interface to user so that user can interact with software. So that user can interact with software. Done. On application layer there are some protocols, right? We will discuss that protocol. See, that protocol is also for network engineer, important for network engineer, application layer protocol. But presentation layer and session layer is not important for network engineer. Okay, so we will discuss about application layer protocol. Just I am giving you one overview of application layer. Okay, so it is clear.
Yes.
It provides the user interface. After that, presentation layer. As I told you that whenever machine send any data to the destination, machine is performing encryption. Yes or no? Otherwise, anyone can read your data on the link. Yes. And sometimes we need to compress the data as well. Like suppose I want to send you the book of CCNA, but the size of a CCNA book is 2 GB and WhatsApp is not allowing me to send 2 GB data. Yes, getting my point. So what I can do, I can compress my file. I can compress in zip. Yes or no? Then I can send you and you can decompress. We are doing this in the general life. Yes or no?
Yes.
So the encryption, decryption, compression, decompression, whenever machine is doing these things, so which layer is doing these things? Presentation layer. Presentation layer is responsible for encryption the data. Let's say my actual data is ABC. So transport layer will, sorry, I'm saying transport, presentation layer will encrypt it into, let's say, 1 2 3. After that it will send on the link, and when receiver machine will receive, see, both machine is using what? OSI model, so both have knowledge about the encryption and decryption algorithm. So this machine will decrypt ABC 1 2 3 into what? ABC.
ABC.
So actually encryption will perform by presentation layer. When you are compressing the data, so physical layer is actually compressing the data. Okay, so here in presentation layer we can say it provides encryption, decryption. At sender machine, presentation layer will encrypt the data. At receiver machine, presentation layer will decrypt the data. After that, compression, and decompression. Or you can say what? Presentation layer present the data in actual format. Yes or no?
Yes.
Done. After that, next layer is session layer. You know, in my browser, let's say here I am typing www.google.com. Google. Here in next tab I am typing facebook.com. In next tab I am typing instagram.com, let's say. Yes. So when reply will come from Instagram server, that will be open in this tab only. When reply will come from Facebook server, that reply will come in this tab only. And when reply will come from the Google server, that will come in this tab only. Yes or no? Have you ever seen that Facebook, you have send request to Facebook server from this tab and the reply is coming in another tab? No. We never see that. Yes or no?
Yes.
Because there is one session layer who is separating the session. So work of session layer is maintaining and terminating the session. Whenever you are sending a request, session layer will start maintaining a session. So it maintain session and terminate the session. Done. Now your actual work start from here, from the presentation layer. So guys, till now is it okay? Upper layer, all upper layer is clear.
Yes.
Yes, it's clear.
Yes.
These are not important for us. Okay, now question is, what is transport layer? So just I am giving you an overview of transport layer. So transport layer, it is
Port address.
or we can say it is responsible for service to service communication. See, through IP address, what we can do through IP address, brother. Let's say I am designing one network over here. This one is my router one. This router is connected with one switch, also with another switch. And here I have one computer whose IP address is 10.1.1.1. Here is one computer whose IP address is 20.1.1.1. So through IP address, or let's say this is a server. This is a server of Google. www.google.com. Done. And IP address of Google server is 20.1.1.1. Done. From this machine, through IP address, what I can do, only I can send packet to this server. But this server will never came to know that user want to access what? Google web page. For that we have a transport layer for the end-to-end communication. This is host to host communication. Through IP address we can communicate one host to another host, but we cannot communicate service to service. Like here application layer want to access the Google web page. So that is not possible through IP address. That is possible through port number. That is possible through port number, source port and destination port. And transport layer is responsible to provide source port and destination port to the data. Done. So what we can do over here? Here we can mention it is responsible to provide source port and destination. We will understand source port and destination port, don't worry. What is port number? This is our one topic. Okay.
Okay.
So till here, just I am giving you one overview of transport layer. So it is clear.
Yes.
Now network layer. So like transport layer is responsible to provide what? Port number. Network layer is responsible to provide logical address, that is IP address.
IP address.
Done. Like network layer is responsible to provide IP address, data link layer is responsible to provide
MAC.
MAC address. MAC address. And physical layer, as you know, physical layer is nothing but your media. Through that your data will flow. Physical layer work is actually it will convert your data,
To
into
binary.
bits. Your data will flow on the link in the form of 0 1 in the bit, yes or no,
Yes.
from in the bits, and then maybe bits to signal, electrical signal or light signal. If it is optical fiber, so it will convert it into light signal, right?
Yes.
Is it clear till here?
Yes.
Now you all guys have installed EVNG?
No, it's not working.
Not working. Then I have to take one session for EVNG as well.
Yes.
See, I am going to capture the link between here, between router 1 and router 2. And there is one application layer protocol called Telnet. You all know about that protocol or not? Telnet? You have heard about that protocol?
Yeah, we have, but not much.
Okay. So we will understand Telnet protocol later. Just I am going to enable Telnet over here so that I can show you one data. Okay.
Yes.
Telnet protocol uses port number 23, line VTY 04, and password is 123, and let's say Cisco, and login and exit, enable password Cisco. Okay. Now from router number, okay, I have enabled Telnet. Let me configure one IP address as well on F0/0. Let's say IP address is 12.1.1.2, 255.255.255.0, no set, and exit. Then on router number 1 also I am going to configure one IP address. IP address is 12.1.1.1, 255.255.255.0, exit. Oh, no sir, yes, done. Now Telnet and 12.1.1.2, trying, and password is Cisco. Now you can see I have Telnet access. Okay, here I'm going to show you the Telnet data. This one is Telnet data. See, this is Telnet at which layer? This is your application layer. This is your application layer. After that, this is your transport layer. This is your IP header, means network layer. This one is your data link layer, and this is your physical layer. Done. So see, transport layer is providing what? Source port number. Here you are able to see source port number, destination port number, and source port number.
Yeah.
Right. There are some more information as well, but don't worry about that. See, transport layer is actually providing source port number and destination port number. In the same way, network layer is providing what? Source IP and destination IP. Yes.
Yes.
In the same way, data link layer is providing what? Source MAC address and destination MAC address. Done.
Yes.
Mhm.
So these three layer is very important, and this one is the primary use of all these three layer. Transport layer is responsible to provide the source port, destination port. Network layer is responsible to provide source IP and destination IP, and data link layer is responsible to provide source MAC and destination MAC. Now you have one more file. Let me open the previous file again. Guys, just give me 1 minute. Someone is on my door.
Okay.
Yes. So we had discussed this thing, okay? OSI model. OSI stand for
System interconnection.
connection. Develop in, okay, you don't need to learn the history of anything. After OSI model, now different vendor devices are able to communicate with each other. It acts as a blueprint. These are the layer of OSI model: application, presentation, session, transport, network, data link layer, and physical layer. Now here you can read something about application layer. Please read. Done?
Yes.
Okay. There are
Yes.
various services like web service, file service, remote access service, like we have configured the telnet just soon. After that, time service, mail service, etc. These are the key function of this layer. Accessing web page is the feature of application layer, right? Time server means your device can synchronize your time with time server, and that is also a function of application layer. Mail server, when you are sending the mail, this is also function of application layer. And these services can be accessed with the help of some protocol. Done. This is very important point, that whatever services we have at application layer, that service can be accessed with the help of some protocol. And the protocol like HTTP, TFTP, HTTPS, Telnet, SSH, SNM, SMTP, FTP, DNS, etc. Okay, these are very important protocol. See, HTTP and HTTPS, these two protocol are used to access web page from the web server. TFTP is used for the file transfer. Telnet is used to take access of networking device remotely. SSH is also used for the same purpose, but SSH is secure and Telnet is not secure. Okay. This SMTP is used to send mail, simple mail transfer protocol. FTP, file transfer. This protocol is also used to send or download the file. Both TFTP and FTP work is same, but there are some difference we will discuss later. After that, DNS. DNS is used to resolve the domain name from IP address. IP address from domain name. Vice versa. Okay. This is all about application layer. Here presentation layer. We had discussed this, that ABC can be encrypted in this. Then session layer. Session layer create, maintain and terminate the session. This is done with the help of session ID. Now the important topic is port number. What is port number? So it is in 16 bits, IP address. Tell me how long IP address is? 32 bits address.
Yes.
Like that, port number is also address of 16 bits. It is in 16 bits address and represented in decimal. So range will be 0 to 2 to the power 16, and 2 to the power 16 is 6553536. So range will be 2 to the power 16 is 65536. So range will be 0 to 65535. Done. Port number is a unique ID of protocol in computer networking. Each application layer protocol or any protocol which work upper than network layer will have one protocol port number. Getting my point? All the protocol which work upper than network layer, like protocol work at transport layer, protocol work at application layer, these protocols uses one port number to identify the services. Like if you are sending a request on port number 443, so Google server will came to know that okay, it want to access 443 service, and 443 service is nothing but web page. Okay. After that, these are very important protocol and port number. So you need to remember this. Port number of FTP is 20 and 21. Secure shell port number is 22. Like this you have to remember. As a network engineer, you have to remember these all port number. Here you have to include DNS as well. DNS is not there. So DNS is also very important. DNS port number is 53. That also you should keep in mind. So this is your second homework. First homework is from subnetting, and second homework is you will remember the port number of these protocol. And at transport layer, two important protocol works. One is TCP and another one is UDP. This is also very important, TCP and UDP. This is the topic for next class. Tomorrow we will discuss TCP and UDP only. So, but for now, just you need to keep in mind that which protocol is using which service at transport layer. Like see, FTP, file transfer protocol, uses TCP service at transport layer. Secure shell is uses both TCP as well as UDP at transport layer. There are only two protocols at transport layer. One is TCP and another one is UDP. Some services of application layer are using TCP and some are using UDP. So you have to keep in mind these protocols only. And DNS. These protocol uses which service at transport layer. Okay.
Yes.
Is it clear, Abdul?
Yes, for me.
Yes,
It's
it's clear.
Okay, great. After that, we have again two types of port number. Like we have two types of IP address, private and public. We have two types of port number. One is well-known port number and another one is unknown port number. Guys, well port number are those port number which we already defined to the protocol, which is reserved, you can say. for the protocol. Like HTTP is using port number 80. So this is reserved for HTTP. You can see range 80 is from this range. That means all port number is from this range only, because these are reserved, well known port number. And unknown port number are free of cost, and which we have not defined to protocol. So these are free. We can use this protocol number as a source port number. Like if my computer is sending one data to Google server. Let's say this is my computer, and my computer is sending some data to Google server. So destination port is well known. Destination port is what? Fix. That will be always 443. What will be the source port? Source port will be any random port number that will be from this range, unknown. See, from your computer, if you are sending one request to Google server, then also port number will be 443 destination port, and source will be any. When Abdul will send traffic to Google, then also destination port will be 443. So doesn't matter from where you are sending request to Google server, destination port will be always 443. That's why we said this is a reserved port number for Google. And source port number will be the random port number. Maybe here my computer is using 1025, your computer is using 1026, Abdul computer is using 1027, anything. So this is not well defined. This is random port number. Is it clear?
Yes.
Yes.
Yes. So see, at transport layer, this layer provide reliable and unreliable communication. As I told you that at transport layer there are two protocols. One is TCP and another one is UDP. Okay, TCP and UDP. TCP stands for Transmission Control Protocol and UDP stands for User Datagram Protocol. TCP is an reliable protocol and UDP is an unreliable protocol. So that's why here I am saying this layer provide reliability and unreliability. Means the protocol which will use TCP, that is reliable, and the protocol which will use UDP, that is unreliable. Done. It perform error correction as well before the transmission. We will understand it. Two protocols are work at this layer, that is TCP and UDP. TCP stands for Transmission Control Protocol. UDP stands for User Datagram Protocol. Everything is here in the file. You can read this file. Okay. After that, there is one more difference. TCP is an connection oriented protocol and UDP is an connection less protocol. So difference is here in front of you. TCP and UDP. TCP is connection oriented, UDP is connection less. Now see, understand first what do you mean by connection oriented and connection less. This is logical connection. I am talking about the logical. This is not about the physical connection. Let's say I am sitting in my studio, and from here I am teaching you from my laptop, right? Here I am sitting. Done. In my next room, in my beside room, my brother is sitting. My brother is there. Done. Now let's say I need one glass of water. I can directly say, hey brother, can you give me a glass of water? Guys, tell me, am I sure that my brother will come with water?
No.
No.
No. Don't know that my brother have listened me or not. But if I will say, hey brother, then he will say, hi bro. Then I will say, please give me a glass of water. This time tell me, am I sure that my brother will come with water or not?
Yes.
So this is a logical connection between me and my brother. Like that, whenever one computer send a traffic to server, computer have two options. Number one, it can directly send the data to the server. That time machine don't have any information that server have received the data or not. So this is unreliable communication, and UDP is doing this. UDP is directly forwarding data to the server. Done. But if I will talk about the TCP, so before sending data, let's say there is one data and this PC need to send the data to server, and this time this service is TCP based. So it is not going to send directly data to server. First of all, it is going to ask to server hi. Then server will say hello, and it will give acknowledgement also that I receive your hi. Then my computer will send acknowledgement that I receive your hello. Done. This is what? A logical connection. And then this computer is going to send the data, and after delivering the data, PC server will give acknowledgement as well. Acknowledgement. So this is nothing but the reliable communication. Yes or no?
Yes.
Yes.
So to build logical connection between source and destination, machine are performing three-way handshake. Three-way handshake. Why we call it as three-way handshake? Because in this process, machine are going to exchange three message. First, computer, server. There is connection. This machine will send one SYN message. SYN message is nothing but TCP message. In the TCP message, there is some field. There is one field called flag field. In the flag field, there is one flag called SYN field. So it will on SYN bit, and it will send one sequence number. Sequence number, let's say 0. When server will receive this sequence message, it will give the acknowledgement. It will send their on SYN message as well. SYN with sequence number 0, and it will give acknowledgement on acknowledgement number 1. Then PC will send what? Acknowledgement on acknowledgement number 1. This is what three-way handshake. With the help of three-way handshake, routers are performing what? Logical connection. Like here, where is my topology? See, Telnet is TCP based or UDP? Telnet. Telnet is TCP based, yes or no?
Yes.
You can see over here. So see, if Telnet is TCP based, that means whenever I will try to form, I will take remote access of router 2 from router number 1, it will first generate what? It will perform what? Three-way handshake. It will perform three-way handshake, and it is going to maintain one table. See, on router number 1, we can check that table by running command show TCP brief. Is there any information? No?
No.
Now I am going to take Telnet access. Telnet 12.1.1.2. Password is Cisco. So enable Cisco and show TCP brief. See, there will be one connection. Are you able to see?
Yes.
There is one connection between 12.1.1.1 to 12.1.1.2. Yes or no?
Yes.
Port number of 12.2 is 23. As I told you that Telnet is using well-known port number. That is 23. So 12.1.1.2 is the telnet server, and router 1 is client 12.1.1. So client is using what? Random port number, you can see. And state is stabilized. Okay. I am going to exit it. See, I am going to capture the link again between router 1 and router 2. I have captured the link. It is sending some other traffic. Don't worry about the other traffic. Now, from router number 1, I am going to take telnet again. Telnet 12.1.1.2. Password Cisco. See, brother, actual telnet message is here. Before sending actual telnet message, it have exchanged 3 messages. Yes or no? Seen, ACK, and ACK. Yes or no?
Yes.
Here sequence number is 0, here sequence number is 0, but acknowledgement number is 1, and here acknowledgement number is 1. Sequence number is 1. Got it?
Yes.
So all TCP based services will build first logical connection. That's why we said TCP is an connection oriented protocol. What we said? TCP is an connection oriented protocol. Here you can see it is a connection oriented protocol. It means it will build first logical connection with the help of three-way handshake. And UDP is an connection less protocol. Means UDP is not going to build any logical connection. After that, here in TCP we can arrange the receiving traffic in sequence. Let's say I am sending 10 packet to server. So server can arrange my traffic in actual sequence. But in case of UDP, it is not possible, because there is no acknowledgement, there is no sequencing. If there is no sequence number, how receiver machine can arrange it in actual sequence?
Sir.
Let's say I am sending you 10 mobile 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And you need to arrange it. So if there is sequence number, then you can arrange it in the sequence. But if there is no sequence number, can you arrange 10 mobile in the sequence?
So I have
No?
a question.
Yes.
Okay, if I request or to Google or from YouTube, or I type like youtube.com, right? How
Okay.
do you know which protocol is this one? Is it UDP, TCP, or which one? Or I don't know.
Okay, you will understand that. Wait for some time, brother.
Okay.
We are going to discuss, whenever you are typing www.google.com or youtube.com, that time that services is using TCP. Whenever we are talking about the video conference, like now we are talking through Google Meet. So here we need fast communication, yes or no?
Yeah.
So it is using UDP. Definitely TCP is slow because there is three-way handshake, the acknowledgement, but in UDP there is no any acknowledgement. So UDP is fast. Whenever we need fast communication, that time we use UDP service. Whenever we need reliable communication, that time we use TCP service. And while developing the software engineer decided that your service is TCP based or UDP based.
Oh, okay. Like we not select like, okay, this is TCP or this is UDP. It will select automatically.
Yes,
Okay.
it will automatically.
Okay, got it.
It is predefined. Okay.
Yeah, I understand that. Thank you.
Now, here data retransmission can be done definitely if there are one logical connection and router are getting acknowledgement. So it can, if receiver will not receive any data, so sender machine can retransmit that. But in case of UDP, retransmission is also not possible. Let's say now in the video conference, this is UDP based. So because of my bad internet, suppose you have not listened me some word have missed on the internet because of bad internet connectivity. Do you think that my machine is going to send that voice again? No, not possible. Yes or no?
No.
While video call on WhatsApp, if your internet is not good and because of that you have missed some voice, you will not receive that voice later. But if you are downloading a movie from a website and you have completed the downloading of 50%, after that your, let's say, internet is not working, and after some time again your network will come up. So if your download is resuming from 50%, that means your service is using what, TCP. Because sender and receiver machine have information that how many data receiver machine have received. Getting my point?
Yes, yes. Now I got it.
Okay, so, and it is also clear to you that when we need to use TCP and when we need to use UDP, when we need fast communication, like in video conference, we need only fast communication. Reliability is not my concern. Here we need fast communication. If communication is slow, let's say I am saying hello, after 2 minutes you are saying hello, in that communication I cannot teach you, yes or no?
No.
So here we need fast communication. So whenever we need fast communication, we will use UDP service, right?
Yeah, sometimes, like when we talk, right? It happened with
Yes.
me when I talk. Then the receiver receive my talk few seconds later. Then I receive his voice like few seconds later. Which protocol is this one?
Maybe that is using TCP.
Okay, okay, got it.
In the TCP only you will get those type of problem. And after some time, if you are using UDP na, so after some time you will not receive the data,
Okay,
right? Retransmission is not possible in UDP. Done?
yeah. And we cannot do like we cannot use TCP by ourselves. Okay, I'm gonna call and I want to use TCP or UDP. They just
Well, TCP chat is your TCP. Like if you don't have internet, if you have sent the message, when your internet will come up, that time it will send, yes or no?
yes, yes, yes.
But video call is UDP.
Got it, got it. Thank you.
Okay. Next is, it is unreliable. Yes, definitely, because we have acknowledgement in TCP, but it is not reliable. Here we can achieve flow control. Here we can, in UDP, we cannot achieve flow control and windowing concept. So this is topic for tomorrow, please.
Okay.
Okay.
Yes.
Okay.
That's all for today. If you have any doubt, you can ask.
Thank you, sir.